let us study inside the atom. Which all things are present inside the atom? For studying in detail about inside the atom, four scientists came forward. First scientist is Dalton, second one J.J. Thomson, third one Rutherford, fourth one Bohr. First we will study one by one. First scientist who came forward to study and to explain about the internal structure or inside the atom, which all things are present. For explaining in detail, first scientist came, his name is Dalton. Then he made his own theory. So that theory is known as Dalton's atomic theory. Dalton's atomic theory. Now, in his atomic theory, he explained about the atom in such a way that atom is a solid sphere. Sphere means ball. Atom is looking like a ball. Now, its inside nothing is there. It is like a ball. So, inside nothing is there. We can say that its surface or circumference, the outer cover of the ball is a solid sphere, as well as we can say it is a hard substance. Now, its mass, the mass of an atom, is uniformly distributed throughout, everywhere. Inside nothing is there, inside fully empty. It is a empty sphere, we can say, nothing is there inside. Then its mass, its weight, we can say, that is uniformly distributed in its outer cover. Inside nothing is there. This way explained by Dalton. After that, other scientist came. Other scientist's name is J.J. Thompson. J.J. Thompson. He said that atom is like a sphere, as he said. Dalton also said the same. It is like a ball. Same way we can say J.J. Thompson also said that it is like a ball. But its inside, it is looking like a plum pudding. Its structure, he said that it is like a plum pudding. You all are familiar with pudding, how cake is there, same appearance. But it is like a ball like a structure, we can say. It is like a round structure is there. How it is there inside the atom, like pudding. How pudding is there? It's inside some kismis, such and such things, raisins, such and such things, middle we are putting it. Then other part some batter will be there. So such a structure is there. So we can say that a round structure, we can say. Ball like, not like a round structure it has. Then one more thing he said that it is like it's inside some what we can say raisins, like here negative charged particles are there. Middle like such a negatively charged particles are present. Such a negatively charged particles, he given the name as electrons. Then here we can say that these negative charged particles embedded in it. How our plum pudding is there, round structure will be there. In that middle we people are putting some kismis, raisins, such and such things. So we can say that that is embedded. Here and there we are putting. Similarly, here also what is there? Electrons are embedded in it. Embedded means middle like that way put it. Then remaining place full. positively charged particles distributed. Remaining places we can see that positively charged particles distributed throughout this plum pudding structure. So we can say that here he said that it is exactly like a sphere, like a ball. But J.J. Thomson said that atom is like a plum pudding, round structure, not like a ball. It is having a round structure inside. We can say that how inside the plum pudding we people are putting kismis as well as raisins. Similarly, he said that inside such a plum pudding structure of the atom, electrons, negatively charged particles are embedded. And remaining part, we can say that throughout, everywhere, remaining part full having positively charged particles. Now, we have to go to other scientist. His name is Rutherford. After J.J. Thomson, a new scientist came. His name is Rutherford. He wanted to prove that inside the atom, whether all positively charged particles evenly distributed or not. For clearing that matter, he done an experiment. That experiment is known as Rutherford's scattering experiment. Rutherford's scattering experiment. For doing this experiment, he had taken one fluorescent screen. Fluorescent, its meaning shining one. Fluorescent screen taken. One thing. Second thing, he taken a foil of gold. Foil of gold, that means foil means a sheet of gold. Now its thickness, that will be equal to 1 upon 10,000 millimeter. So we can say that 1 millimeter thickness is there. Such a gold sheet he had taken, then that thing cut it into thin slices. How many thin slices? 10,000 thin slices he made. Then one slice will be having how much thickness? That is 1 upon 10,000 millimeter. Or we can write it as 10 raised to minus 4 millimeter. Such a thin sheet of gold he had taken. We can say that even we cannot be able to see. That much thin sheet is that. That he put it inside that screen. After that, he had taken one box. Inside the box, one radioactive element he put it. Now the box inside, he put it what? A radioactive element. Radioactive element's speciality, it is having the capacity to emit different types of rays. We can say that alpha, beta as well as gamma rays. Now, he taken such a box and allowed only alpha rays to come out. Remaining rays absorbed by the absorbent which is kept inside the box. Now, the alpha rays which is having positive charge, when it will go and hit on the gold piece, if the gold piece inside all atoms are there, inside the atom full of positive charged particles are there, alpha also having positive charge, gold also having positive charge, then what will happen? The positive charged particles, between them there will be a repulsion will occur. If repulsion will be there, that means it will come back. That means alpha particles will come back. it cannot be able to pass through the gold foil or gold sheet. Now, how did he do? That experiment I will be showing you. Just imagine screen, how did he make, that I am saying you. Like that way one sheet he taken, then he rolled it like this. Such a way he rolled. Middle he kept one slit. Slit means a gap he kept. Inside he kept the gold, very thin sheet of gold inside this screen. This screen you consider as fluorescent one. Light emitting power is there. Its inside he kept the gold piece. We can say a sheet of very thin gold sheet. After that, just imagine he taken such a box. But this is just an example I am showing you. But inside this box, radioactive rays emitting power is there. Such a type of elements he kept it inside. Then it's inside. He drilled. Drilled means he made a hole. After that, it's inside he kept the radioactive element. Now this radioactive element is having the capacity to emit alpha, beta as well as gamma rays. These all are different types of radioactive rays. So alpha, beta, gamma. These all rays emitting power is there. The radioactive element which is kept inside. But he allowed only the positive rays to come out. This is alpha rays which is having positive charge, beta rays having negative charge, gamma rays having no charge. We can say it is neutral or chargeless. So gamma rays does not have any charge, beta rays have negative charge, alpha rays have positive charge. He allowed only the positive charged rays to come out, and he allowed only positive charged particles to hit on the gold plate. After that, which all things happened? That I am saying you now. As and when this positive charged particles went towards the gold foil, he noticed that, as a surprise we can say, he noticed that most of the alpha particles passed through the gold foil. Only very few turned. I am showing you now. This I am showing the nucleus part. Here all middle. I am showing electrons and negatively charged particles like that. As and when he passed positive charged alpha particles, like that way he allowed the positive charged particles to pass through the gold foil. He found that most of them moved straight without any deflection. No deflection happened. They moved straight through the gold foil. One or two, he found that it is just when then hit on the nucleus part, straight it is gone there and it is went back. We can say that 180 degree we can say. So same to same, that means it is unable to pass through. Straight, it went towards here, afterwards again it went back. Few he seen that some of them turned or deflected with different angles. Some of the rays, like that way, some of the rays he found that they went back with different angles. Few of them. Maximum, majority or most of the rays went straight without hitting anywhere. Some of them went back with a different angle. Some of them with a little angle or small angle. Some of them went back with a 90 degree angle, 80 degree angle like that. Very few, one or two went back with a 180 degree angle, we can say. Straight to straight it went back. Through which line it came? With the same line it went back. Seeing this, he said some conclusion. He said that at the center of the atom, just imagine this is the atom. At the center of the atom, there is a heavy nucleus is there. A heavy nucleus is there that is having positive charge. So he said that inside the atom there is a heavy nucleus is there which is having positive charge, or we can say which is having positively charged particles. And he said that around this nucleus there are number of negatively charged particles. These negatively charged particles are known as electrons. These negatively charged particles are known as electrons. These negatively charged particles keep on revolving or keep on moving one after other. Then this positively charged particles are known as, here full we can say, inside the nucleus full positively charged particles are there. To them we can call as protons. Now again he said that inside this nucleus the mass of the whole atom is concentrated. So mass of the atom is concentrated at the center of the atom, that is its nucleus. Now one more thing he said that here these electrons which are around the nucleus, they keep on revolving inside the atom around the nucleus. As a result of it, their energy level keep on reducing. That way he said. But here what is the problem? If they keep on revolving, their energy level goes. If their energy level goes, then the atoms of all elements will be unstable. He said that all electrons are revolving around the nucleus. As and when they revolve around the nucleus, their energy level goes down. If their energy level goes down, then they will be unstable. But actually all atoms are not unstable. Only radioactive elements like, we can say that radium, thorium, polonium, etc. They are radioactive elements, they are unstable, but not all atoms are, or not all atoms of elements are unstable. So due to this, his atomic model or his atomic theory unable to accept by public. After him, other scientists came. His name is Bohr, or we can say the full name of him, that is Niels Bohr. Now, we can say that Dalton's atomic theory, or Dalton came in the year 1803. After that, J.J. Thomson came in the year 1904. After that, Rutherford came in the year 1911. Then last, Niels Bohr came in the year 1913. Rutherford said that electrons are moving around the nucleus. As and when they move around the nucleus, their energy level keep on reducing. As a result of it, there should be all atoms in unstable condition. That was the mistake done by Rutherford. Now, when Niels Bohr came in the year 1913, he explained the structure of the atom in a different way. We'll see the structure of the atom. At the center of the atom, there is nucleus, which is having positive charge. We can say that they have, nucleus is having positive charge. As Rutherford said, it's a full mass. Full mass of the atom is concentrated at its center. The central part of the atom is the nucleus. Now, around the nucleus, there are number of concentric orbits. Now, what is meant by concentric orbits? Now here I am making number of orbits. Here what is meant by concentric orbits? Concentric orbit means there will be one center. Around that you can find that number of orbits. Each and every orbit, they all are having circular shape. Their center will be one point, we can see. Center of each and every orbit will be at the same nucleus, we can say. Central region, that means we can say that that is the nucleus. So this nucleus will be the central point of each and every orbit. So all these orbits are known as concentric orbits. Now the first orbit he given the name as K shell, second one L, third one M, fourth one N, then fifth one O, sixth one P, seventh one Q. So like that way he given the name to each and every orbits as K is the first name, L second orbit, third M, N, O, P, Q. Last orbit is Q orbit. Now other thing, each orbit will have number of electrons. It's a number not saying now. Different number of, just imagine now different orbits will have different number of electrons. So I am not writing correct number now. Like that way different number of orbits having different number of electrons. Different orbits, it has different number of electrons. Just imagine that way. Different orbits are there. They will have different number of electrons. It's later. Their number means later you will study. But now you think that each and every orbit will have different number of electrons. One more thing. Now I taken, this is the first orbit. First orbit I made now 2 electrons. We can say that the energy level of this orbit, how many electrons are there? All electrons will have same energy level. That means in an orbit, how much electrons are there, all will have same energy level. Now if you are thinking of this orbit, in that now I made only 2 electrons. These 2 electrons will have same energy level. Now here, this is the last orbit. In that I made now 1, 2, 3, 4. 4 electrons I made. All these 4 electrons will have same energy level. Now, when an electron, now suppose from here, from this orbit, an electron is, this is we can say that inside part. This is the outside part or outside orbit. These are inside orbits. Now from here, suppose this electron is jumping into the other orbit. This electron is jumping to other orbit. So what will happen? This electron absorbs. That means inside part, here these electrons will have less energy. These electrons will have little more energy. This orbit has how many electrons? They will have little more energy. This orbit has how many electrons? That will have little more energy. The outermost orbit will have maximum energy. Now here you see this electron jumping into here. That means this orbit has how many electrons? They are having more energy compared to this electron. As a result of it, this electron absorbs energy more. As a result of it, how much energy required? Here, that much energy is absorbing by this electron and it is jumping towards here. As a result of it, required energy is absorbing by this electron and getting the required energy of these electrons which are there in the orbit. But at the same time, this outermost orbit has how many electrons are there? They are having more energy. Out of them, suppose one electron want to go inside. That particular time, this is having maximum energy now, these electrons. But it has to jump inward. As a result of it, how much more energy it has? Now when we are comparing these electrons and these electrons, you will find that here less energy will be there. At the same time, it will be having more energy. So for getting less energy, it will emit extra energy from the outermost electron. After that, it will be equalize the energy level as these electrons and it will enter inside. So here outermost electrons which are having more energy, they remove the energy and they equalize the energy with the electrons which are there in the nearest orbit. At the same time, which are having less energy, they absorb more energy and they equalize their energy with the outermost orbit or next orbit which is near to it. So like that way, some electrons will absorb more energy to equalize their energy level with the orbit where they are jumping to. Similarly, outermost one removes extra energy from it when it is jump inward. Then it will equalize the energy level which is there in the nearest orbit. That will be having how much electrons? That will have equal number of or equal energy level. So we can say that one orbit has how much electrons are there, all will have equal energy level. Now suppose if you are seeing this orbit, in that how much electrons are there, all will have equal energy level. As a result of it, atoms are remaining in the stable condition. This is explained by Niels Bohr. Thank you.